Okay. Okay, can you hear me? Yes, I think. Oh, now 46 no. Okay, so please start. Okay, the vernier caliper is completed. Okay, the vernier caliper completed. Today we're going to discuss our next length measuring instrument, that is micrometer screw gauge. Micrometer screw gauge. This is the sorry, micrometer screw gauge. Micro. Okay, these all parts we already discussed. Positive zero error, negative zero error of the vernier caliper, and what is the zero error of any type of instrument already completed. Okay. Okay, come to the micrometer screw gauge. The micrometer screw gauge, same as vernier caliper, it's also length measuring instrument. The micrometer screw gauge also length measuring instrument, and that we can use for get smallest length, small length, small intervals we can get by the micrometer screw gauge. Do you remember what is the main principle of the vernier caliper? Do you remember? Do you remember what's the main principle of the vernier caliper? Anyone? The main principle of the vernier caliper, some parts on main scale 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this, some amount of parts divide into equal parts by another scale. No? That above part we called as a main scale, and the below small part, moving part, we called as a vernier scale. Do you remember? Vernier scale. Then some amount of parts on main scale, some amount of parts on main scale, divide into equal parts by using another scale that we called as vernier scale. Okay, that is in vernier caliper. It is in vernier caliper. But now we're going to discuss what is the relationship, what is the principle of the micrometer screw gauge. What is the principle of the micrometer screw gauge? Okay, in micrometer screw gauge, the difference, the board clear, no? Can you confirm? Is it clear? I think. Send me message. Everything okay? Okay, no? Okay. Give me a second. I want to plug my charge. Okay, sorry. Now, okay. Okay, I told you in vernier caliper, the principle is some parts of main scale, some amount of parts in main scale divided into a some amount of equal parts by another scale that we call as vernier scale. That's a main scale. The above one is a main scale. This one vernier scale. හරිද? මේකේ main scale එකේ parts ගානක් vernier scale එකට divide කරලා දාන එක තමයි divide into equal parts that we call as a principle of vernier caliper. But this same principle applied into different form for the micrometer screw gauge, but same principle, but the application is different. The difference is the principle of the micrometer screw gauge, that's a screw divide into a equal parts and mode along the circular scale. That is the difference. In vernier caliper, there are two scales. I think you can remember. The above scale is main scale and the below moving one is vernier scale. The important thing is in vernier scale, main scale and vernier scale both linear scale. They come a linear scale like as straight lines. Okay, main scale and vernier scale both linear scale. The difference in micrometer screw gauge also there are two scales. The first one we called as linear scale. The first one is a linear scale and the other one is a circular scale. Okay, the other one is circular scale. That's the main difference. Okay, I will show you directly. The principle of the micrometer screw gauge, some amount of parts of main scale. Focus කරන්න. Some amount of parts on main or linear scale divide into some amount of equal parts by a circular scale like this. 1, 2, 3, 4, 5. It's a circle. 45 like circular scale. That's only difference. Okay, I got the difference. In main scale, there are two scales. The first one is main scale. In vernier caliper, there are two scales. Vernier main scale and vernier caliper, both linear scales. They come linear as a line. But if we consider about micrometer screw gauge, in micrometer screw gauge, one scale is linear scale and the other one is circular scale, like a rotating drum. As example, it's just like a rotating nut. Okay, I will explain everything. It's just like a rotating okay, now I don't have. I'll show you what is a. Do you know how we use a screw? Screw එකක් use කරන්නේ කොහොමද කියලා දන්නවද? Screw, bolt and nut. Sadev, do you know how to work a screw? Screw mean like this. Screw. like this. Think this is a nail. This is a nail, and it has thread like this that we call as threads. Threads. Okay, that we call as thread. Then if I rotate a nut of this, rotate a nut. Rotate a nut. Okay, I'll change the side for better understand. Like this. Like this. Now, if I rotate this nut into above direction, I make a above direction rotate like this. If I rotate like this, then what happened? It is moving and tightening or releasing. Make a nut. This is a nut. This is a nail. Screw nut and screw nail. Sandeep, if I rotate into upward direction like this, it is tighten and releasing. Tighten or releasing. Tighten or release. Quickly. Is it tighten or releasing? I am asking simple screw. Okay, I am asking if I rotate into upward direction like this, upward direction like this, okay, like this, it is rotating into upward and it is moving to this side. No? Can you understand? If not, please send me. They are practical things. If I rotate, think I will show you very simple example. Yeah, I will take a nail. Okay. Very good. It is tightening, not releasing. Okay, think this is a nail. Okay, this is a nail. If I today I don't have nut, I think very simple thing. I asking this is screw, adding screw nut. If I rotate into this side into upward, it is tightening or releasing. It is tightening. See the pattern of the trade patterns. I think you can clearly see the trade patterns. If you see the trade patterns, when I rotate into upward always, when we rotate into upward, it is rotating and moving into left side direction. If I rotate into downward direction, opposite side, it is, if I rotate into downward direction, it is rotating and moving to this side. Understood? The simple practical. Sadev, Sandeep. Yeah, when we rotate into upward direction, always upward. It is rotating and going to this side, tightening. If I rotate into release, left side direction, left, rotation direction is always left. Sorry, not left, downward direction. If I rotate in downward direction, it is releasing. It is releasing. Sadev, are you good? Yeah. Now, the same principle used in a micrometer screw gauge. Okay, the micrometer screw gauge, it is very simple instrument. The difference between vernier caliper and micrometer screw gauge, in vernier caliper, there are two scales. There are two scales 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, continue up to 15 centimeter. I told you. Then the vernier scale is only like small one. Like this. This is a 10. Okay, that is a vernier caliper. Vernier scale and main scale. The above one we called as main scale. This one vernier scale. The moving scale is vernier scale and main scale. You can see some amount of parts in main scale divide into equal parts by vernier scale. Then two scales, both scales are linear. Make a circular mukut naha. That's the difference. Both scales are linear scales. Both scales are linear scale. Both scales are linear scale. But in micrometer screw gauge, the main difference is it has linear scale and circular scale. Some amount of parts on the main scale divide into equal parts by a circular scale. I got the difference. In vernier caliper, there are two scales, both linear. Main scale and vernier scale, both linear scales. But in micrometer screw gauge, there are two scales, some amount of parts in main scale. That's the main scale. I will let you know how to mark these values. How to mark these values. Think there is a linear scale and it has a circular scale. The circular scale is like this. Circular scale. 50. Sorry, 5. 5. Circular scale is like this. Normally, circular scale, there are 50 parts. There are 50 parts in the circular scale. Now, can you understand the micrometer screw gauge is an instrument that we can use for get small measurement, small length measurement by dividing some amount of parts on main scale, divide into equal parts by a circular scale or rotational scale. That we are called as the principle of the micrometer screw gauge. The simple meaning, some amount of parts on main scale, or it is given linear scale, linear scale, some amount of parts divide into some amount of equal parts. You can make a kotas equal ganakat. That's the difference. Some amount of parts on main scale divide into some amount of equal parts by circular scale. Circular scale. Now you should know, in vernier caliper there are two scales, main scale and vernier scale. But in micrometer screw gauge, that we called as linear scale. Linear scale. This one we called as, this rotating one we called as circular scale. Circular scale. Circular scale. Okay, that's the main difference between circular scale and linear scale, including micrometer screw gauge and vernier caliper. In micrometer screw gauge and vernier caliper, the main difference, in micrometer screw gauge there is a circular scale, but in vernier caliper it has only two linear scales. I got the basic difference between vernier caliper and micrometer screw gauge. The main difference, only micrometer screw gauge has a circular scale. I got. Okay, actually, don't think about that. This micrometer screw gauge is very simple. Only difference you need to understand. Very one point only I explained. Okay, in our long discussion, only one point I explained. In vernier caliper, there are two scales: main scale and vernier scale, both linear scales. But in micrometer screw gauge also there are two scales. One scale is linear scale, second scale is a circular scale. Some amount of parts of main scale or linear scale divided into equal parts by a circular scale in micrometer screw gauge. Understood? That's only one point I explained. Okay. Sadhdev, clear? Okay. Okay, now if you go to parts of this micrometer screw gauge, parts of this micrometer screw gauge, okay, parts of this micrometer screw gauge, this is the shapes of the micrometer screw gauge. Okay, now that's the place we hold the object. This is the place we hold the object. That is object. Think this is object. Now the object is placed between the anvil and spindle. This small part we called as anvil. Anvil. Remember that. Okay, this is anvil. Anvil. Okay, give me a second. Let me show a working simulation for better understand the problem is made. Laptop still start. Okay, go to the parts. Anvil. Always the object place close to the anvil. And spindle. Spindle opposite side we tied the object between. Okay. This is the frame. That's the frame. Every parts are connected to this frame. Every parts are connected to this frame, and it has a locking lever. Locking lever, and that we called as main scale. Main scale, and the circular scale that we call main scale or linear scale. The linear scale also possible. Linear scale. Linear scale. That's the circular scale. It is rotating scale that we can rotate as a nut. That we can rotate as a nut. And this one we called as thimble. This small part is a thimble head. Small part is a thimble head. Small part is a thimble head. Okay, please get familiar these parts. Otherwise, you can't understand. Get familiar. Please go through again these names: anvil, spindle, sleeve, thimble, thimble head, linear scale, circular scale. Okay, what are the parts? Anvil, spindle, linear or main scale, and circular scale, thimble head. And all parts are connected to the frame. And there is a locking lever. This locking lever we use to lock the circular scale. I'll let you know, and I'll show you now. Give me 1 second. It is still making. Still stuck. Please give me 1 minute. There is a doubt here. There's a problem with my laptop. Oh, sorry. File and oh, very sorry. Finally, it's working. Okay, this is the micrometer screw gauge. This is a micrometer screw gauge. Okay, now I will show you what are the parts very clear. Okay. Okay, before you understand parts of the micrometer screw gauge, you can hear me, no? Okay. Before we understand the parts of micrometer screw gauge, better to understand what is the working principle of the micrometer screw gauge. Okay, now can you see here? Okay, when I rotate that, so okay, if I rotate by this circular scale, normally we can rotate by thimble and thimble head. The circular scale we rotate by thimble and thimble head like this. When it is rotating to downward direction, see what happened? It's rotating and releasing, no? When we rotate into downward direction, it's rotating and releasing, no? Releasing. If I rotate into upward direction, circular scale rotate into upward direction, what happens? Rotating and tightening. Same as explained the principle. Same as I explained the principle, when I rotate into upward direction, see, when I rotate into upward direction, it is rotating and tightening. Okay, see the spindle, when I rotate into, when I release in this, when I rotate into downward direction, it is rotating and releasing, the circular scale releasing, the screw is releasing. Therefore, this spindle also come into right side, move into right side like this. See, move in right ticket, move into right side. When we rotate into upward direction, the screw tightening, Fatima, I got screw tightening, and the spindle move into the anvil direction. Spindle move into anvil direction. Okay, now I will show you what are the parts. Okay, these parts you need to remember. What you must remember. Okay, that we called. Okay, this one we called as anvil. Remember, ANVIL, anvil. This part is, it is not moving part, it is a fixed part. The name we called as anvil, ANVIL. This one we called as, it is moving part. When I rotate circular scale, this spindle is moving. The name is spindle. Spindle. SPINDLE, spindle. And there is this simulation not clear, this locking nut that we called as locking lever. Locking lever. Locking lever. Okay, the linear scale. This is the linear scale. Linear or main scale, both correct. Linear scale. Linear scale is more accurate. This is circular scale, as you already know. This is circular scale. Circular scale. And this rotating part we called as larger rotating part we called as thimble. Larger rotating part called as thimble. This part, this small rotating part we called as thimble head. thimble head, or there is another name that we call as ratchet. Ratchet ratchet. The ratchet name not given in the tube, you can note down. Ratchet, R-A-T-C-H-E-T, ratchet, ratchet. Okay, they are the basic parts, and that curve surface, U shape part we call as frame. Okay, they are the basic parts of the micrometer screw gauge. I got Ahmed Violet. Okay, now okay, Iris. Now, how we take a measurement using this micrometer screw gauge? Very important practical. Okay, think I want to get the I have object here. I want to get the thickness of this rod. Okay, now I have small rod. I want to get the thickness of this rod. I want to get the thickness of this rod using micrometer screw gauge. Okay, clearly understand the step of using micrometer screw gauge. First of all, the particular object you just need to measure, need to keep close to anvil like this, close to anvil. Need to place close to anvil, and we need to start rotating. We need to start tightening by the thimble, not the thimble head, not the thimble head. We need to start rotating and tightening by thimble. When the spindle coming close to the thimble object, coming close to the thimble, okay, make a longer edge. We need to stop rotating by thimble. Understand very well. When the spindle coming close to the object, the spindle like object take a longer avama, we need to stop rotating by thimble, and we just need to start rotate only by thimble head. Do you know what is the reason? The reason is this thimble head is you can see when we tightening the difference, the thimble head is a fine adjustment. When we rotating by the thimble head, it is slowly tightening because this thimble head part is small. Then when we rotate by thimble head, you can see it is tightening. When it is tightening into maximum, can you hear? There is sound coming. Okay, now can you see this? Can you hear this sound? Like tick tick. You can't hear now. Can you hear? Wait. Can you hear this? No. Special sound is coming. Okay, when it is rotate in required tightness, when we rotating by thimble head or ratchet, it is coming sound and like creak like sound. For the sound, the thimble head start to rotate freely. Then when we rotating by thimble head, the object not tightening, it is freely rotating after tight into required level. That is the main function of the thimble head. That's the main function of the thimble head. We can, okay, can you suggest what is the main advantage of using thimble head for tightening process? What's the main advantage? What's the main advantage of this thimble head? Can anyone send if you got that we call as ratchet? What is the main advantage? Sandeep, Sadev, what is the main advantage while we tightening by ratchet or thimble head? What's the main advantage? I told you now when I rotate by the ratchet, after tightening to required amount with required tightness, it is start to freely rotating with south. Okay, Sandeep, you are one also correct. But the main advantage of this thimble head, we can avoid over tightening of the object. I got making adjust karaddi when it is tight into required limit, again not tightening. It is start to freely rotate. It is a free rotation. Start to freely rotate when it is tight into required level. I got Fatima, Ahmed. When we rotate by thimble, when it is tightened into required level with required tightness, it start again. It's not tightening. It start to rotate freely without tightening. Then we should identify the object tight into required level. I got Sadev. I got. Okay, let me show again how to use this micrometer screw gauge. What is the first step? You need to take a object, and measuring particular object, you just need to place close to the anvil, and we need to start rotating by thimble. When spindle move close to the object, we need to start rotation by thimble head. Now you can see special sound. When it is tightening to required level, it is start to freely rotate with specific sound. Then it is a sign we can identify it has rotate. It has tight into required level. Tight again, no need to tight. Again, no need tight requirement. Then that using main scale, using these values, using this linear scale and circular scale values, we can get the measurement. I got? Yes, very good. Okay, go to the tute. Okay, every parts I have given in the tute. Okay, every parts, thimble head. Thimble head, there is another name that we call as ratchet. R-A-T-C-H-E-T. Ratchet. Okay, they are the all parts. Okay, functions of each part of micrometer screw gauge. Functions of each part of micrometer screw gauge. Okay, start to writing with anvil. anvil. What is the function? Place the object. Place the object. Place the object to get measurements. To get measurements, the object placed close to the anvil. Close to the anvil. Okay, go to the second part. Spindle. Spindle. Please write with me. Note down with me. Spindle. What is the function? Spindle. 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 Tied the object. Tied the object with spindle. Sorry, with anvil. To get measurements. To get measurements. To get measurements. Okay, they are the main functions of anvil and spindle. Okay, please note down quickly. Please note down quickly. Quickly note down. Okay, complete. Third one. What's the third part? Third part, linear scale. Linear scale. Linear scale. Please write the function of the linear scale. Get the linear scale measurement. Get the linear scale measurement. Linear scale measurement. According to the, I'll explain later these things in the measurement reading. Measurement reading, you will have full idea. Get the linear scale measurement according to the circular scale position. Circular scale position. Position. Okay, let me show you how we get the identify this reading measurement reading part in our next class. Next part. Okay, the next one is circular scale. Circular scale. Okay, circular scale function, please write down. Get the circular scale measurement. Circular scale. I write as CS, circular scale measurement. Get the circular scale measurement according to coincide parts. Coincide parts. Okay, let me show you what are the coincide part, how we calculate the count coincide part, everything I will let you know. within few minutes. Okay, today I hope to complete up to measurement reading. Up to measurement reading I will cover. Therefore, don't miss any part of today's session. Today's session is very, very important for your future, because we have only next week we complete in the lesson, measurement lesson. We can complete the lesson. Very simple part we have after this micrometer screw gauge. Okay, circular scale. What else? Other parts? The thimble, 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 spindle, moving, moving toward to the object. Only towards to the object. The spindle moving towards to the object only by doing by thimble. The final one, thimble head. Thimble head. I think you have space. I'm writing with large letters. That's why I don't have space. Okay, thimble head. Thimble head is the most important part of the micrometer screw gauge. What is the function? Hide the object. Hide the object between anvil and I'm writing here anvil and spindle. Anvil and spindle. Tied the object between anvil and spindle only with required tightness. Required tightness. And avoid over tightening. That is very important. And avoid over tightening. Avoid over tightening. Avoid over tightening. Okay, they are the main functions of every parts of the micrometer screw gauge. One part we missed, the locking lever. What is the function of locking lever? What do you think? Can you suggest the function of locking lever? What's the function of the locking lever? Locking lever? Locking lever? Locking. This one? This one, locking lever? What's the function? That we can use to lock the circular scale. Okay. Think when we tie it into required level, if you want to separate the object, if you want to get out the object, we can use this locking lever. We can lock this and take the object out. Then again it is not moving anywhere. We can get the accurate measurement. We can keep that accurate measurements more time by using this locking lever. Okay, I got functions of every parts of micrometer screw gauge. I got Any doubt? Understood? I got any doubt? Please ask. Every part's functions you should know separate. Okay, please send me. I got Sadev, Sandeep. You should know every part's functions separately. Okay, now can you send me the ratchet is the most important part of this instrument. What is the exact function of the ratchet? Type and send me. I need answer from all. What is the main function of the ratchet? How that can be calculated? Please type your answers. I just turn to Guys, what are the answers? It means moving the spindle away from the anvil. Now I am asking how we explain the main function of the thimble head or ratchet. Ratchet. Previously I told you different one. Ratchet tires, thimble head. Please send me, Sadev, what is the main function of the ratchet or thimble head? How that can be explained? That part is very, very important. Very good. Ensure uniform measuring pressure and preventing over tightening. Yes, that's the main function actually. Yes, that we can use the between anvil and spindle, we can tight the object in exact required level and we can avoid over tightening. Then uniform measurement we can get without personal errors. You know, a lot of in vernier caliper, that's a problem. In vernier caliper, don't have any measurement about the tightness. About tightness, don't have any measurements. Therefore, when we tightening, it is possible to deforming. But this instrument, this disadvantage has fixed. Okay, the problem has fixed here. I got the Sandeep. I got. The problem has fixed now. Using thimble head, we can tight the object only in required tightness. We can avoid over tightenings. Avoid over tightening. Others, I got. Any doubt up to now? We discussed parts of the micrometer screw gauge and how we use this, how we get a measurement using micrometer screw gauge. And we already discussed what are the main functions of each part of the micrometer screw gauge. If you have any doubt up to now, please ask me. Don't have doubt? Sandeep? Okay, wait. Okay, they are the main functions of each part of micrometer screw gauge. And in here, I have in this 2 paragraph, I have explained well what is the main function of the ratchet. The ratchet is main part, very important part in the micrometer screw gauge, and it is very helpful for take and keep uniformity of the measurements and reduce human errors. Human errors are main problems while we taking measurements. Human errors are main problem. Therefore, as example, in my vernier caliper, they don't have a measurement about the tightening. Therefore, sometimes person to person, the tightening amount is different. Person to person, it is different. But using micrometer screw gauge, due to the mechanism of the ratchet, any person tight into uniform level up to the required limit. After required limit, it is freely rotating. No again tightening. I think you everyone got the meaning of the function of the ratchet. Ahmed, I got the ratchet, the function of the ratchet or thimble head. Could you please send me? I got. Okay. The linear scale. Linear scale. Okay, now I'm going to explain what is the nature of what is the nature and how they are calibrated one by one every parts of the micrometer screw gauge. Okay, first of all, I'm going to discuss about this linear scale. The linear scale, as I explained, this is the nature of the linear scale. Okay, this is the linear scale. The linear scale, it has calibrated on a iron sleeve. Iron sleeve can that's a metallic sleeve like a cylinder. Okay, like a metallic cylinder like this. I'll show you now. Like a metallic cylinder. See, this is the linear scale. Okay, this is the linear scale. The linear scale. Actually, in linear scale, the maximum value of the linear scale, remember, it is 25. The maximum number of linear scale 25 millimeter. Then you can see the maximum value that we can measure by the micrometer screw gauge 2.5 centimeter. That means millimeter 25 millimeters only. Only small measurement, tiny measurements only we can measure by this micrometer screw gauge. Okay, the linear scale is like this. It has calibrated on an iron sleeve, and this there is a line that we called as a middle axis of the linear scale. That we called as the middle axis of the linear scale. Middle axis of the linear scale. Middle axis of the linear scale. And the calibration like this. It is starting from 0, 1, 2, 3, 4, 5. 5 by 5 it has calibrated. 6, 7, 8, 9, 10 calibrate. 11, 12, 13, 14, 15 calibrate. 16, 17, 18, 19, 20 calibrate. 5 by 5. Okay, that's the maximum value. 25 is the maximum value. This is the linear scale. This is the linear scale. It has calibrated on this type cylindrical iron rod. And there is another thing you just need to understand. Okay, every 1 millimeter on the main scale or linear scale divide into 2 parts in the below like this. Now that we can read, okay, it is like this. Okay, I will show you. This is 0 and 0.51, 1.52, 2.53, 3.54, 4.55. That's how you just need to read 0, 0.51, 1.52, 2.53, 3.54, 4.55, 5.56, 6.57, like this. Okay, therefore it has calibrated 0.5 millimeter to 0.5 millimeter. Understood? That we called as a linear scale. Okay, that is the nature of the linear scale. I'll let you know. I'll show you. Okay, see this. Okay, this is linear scale. See this. This is the 0. That's a 0. This is a 0. 0.5, 1. I think there's a problem with internet. Oh, sorry. Now is it clear? This value is clear, no? Value is clear, right? Sandeep, clear there. Okay. Now you can see it is starting from 0, 0.5, 1.5 to 2, 2.5 to 3, 3.5 to 4, 4.5 and 5. That's how we need to read the linear scale. 5.56, 6.57, 7.58, 8.59, 9.5, 10, like this. Understood? Okay, that's the nature of the linear scale of micrometer screw gauge. And what is the maximum value of the linear scale? The maximum value is 25 millimeter. 25 millimeter means 2.5 centimeter. 2.5 centimeter. 2.5 centimeter is the maximum value of the linear scale. That means the meaning of this, the maximum value that we can measure by the micrometer screw gauge, it is 2.5 centimeter or 25 millimeter. Understood? The maximum value that we can measure by micrometer screw gauge, 25 millimeter. That you need to remember. Okay, understood? The linear scale. Linear scale. Fatima, I go to linear scale. Ahmed. Ahmed. I got. Good. Okay, now let's move into circular scale. Before that, please draw a sketch of draw a sketch draw a sketch of linear scale on your tute. Sketch of linear on your tute. Okay, draw like this, very small party now. This is the circular scale. This is a linear scale middle axis, and this it is starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. Okay, that enough. And mark the maximum value 25 millimeter or 2.5 centimeter. Okay, note down like this. Note down like this. Quickly. Okay, complete. Complete. Okay, now before screw gap, go to the circular scale, next page. Okay, circular scale. The circular scale is actually rotating scale. It is rotating one. Okay, the circular scale is like this. Circular scale, if it is, think this is the linear scale. This is a linear scale. This is a linear scale. Now you already know everything. And this is the circular scale. Circular scale, it's just like a rotating drum actually. When we rotate circular scale along linear scale, it is moving. It is moving, rotating and moving. Okay, it's like this. It has calibrated like this. Normally, it has calibrated up to 50 parts. That you need to remember. It has 50 parts. 50 equal divisions. 50 equal divisions. Okay, of the body of this cylinder. It is like this. Okay, I will show you. I'll show you. Okay, this is the circular scale. This is a circular scale. This is a 0. This is a circular scale 0. And you can rotate and see. Okay, now see when we rotate this. Okay, it is 5, 10, 15, 20, 25, 30, 35, 40, 45, 46, 48, sorry, 46, 47, 48, 49. The 50th one again 0. Then overall, it has 50 parts. 50 parts. 50 equal parts. 50 equal parts. Okay, this is the circular scale. This is the circular scale. Circular scale divided into 50 parts, 50 equal parts. By rotating divisions of the circular scale distance, mode by screw is least count. That I'll explain in the next part. What is the meaning of the least count? Before that, I got the nature of the linear scale and circular scale. Please send me yes or no if you have any doubt. Linear scale and circular scale, are you got the nature? Sadev, the linear scale and circular scale, I got. Good. Others? Sandeep? Yes. Ahmed? Circular scale and linear scale. I got the difference and I got the nature and their calibration types. Okay, very good. Now we go into very important topic here that we called as screw gap. There is another name that we call pitch. Okay, what is the meaning of this pitch or screw gap? Okay, if you consider a screw nut or screw nail, the screw gap is the gap between two pitch, gap between two threads. When make, I will show you. The gap between two threads, like this. The gap between two threads we called as a screw gap. But this one. The gap between two threads. See, the gap between two threads we called as a pitch or screw gap of this type screw nut, not screw nail. Screw nail, the gap between two threads we called as a screw gap. But the problem is, in micrometer screw gauge, there is no any screw, there is no any threads. Then how we define this screw gap? Screw gap has specific definition that you need to remember. In exam, there are lot of time it is asking the same question, what is the meaning of this screw gap? The screw gap mean while rotating one revolution of circular scale along linear scale, circular scale moving distance, that we called as a screw gap. මොකක්ද screw gap කියන්නේ? While rotating one full revolution. One full revolution mean you can see now the circular scale on the circular scale 0 and linear scale middle axis coincide. You can see this middle axis and this 0 coincide. Okay, now you already know what's the meaning of the coincide. We already discussed in the vernier caliper. Okay, now this circular scale 0 and linear scale middle axis coincide, and the final value that we can see, actually the value is 20, 21, 23, 24, 20, 21, 22, 23, 24 is the value. Okay, 24. 24. Okay, this is a 24. This is a 24. Okay, while rotating one revolution, see, now it is 0. Now 0 to 0 coincide. 0 to 0 coincide while rotating one revolution. One revolution means rotate after getting to 0. Rotate and get again into 0. See. Like this. Now what is the value? 23.5. Then what is the screw gap of this instrument? The screw gap is 0.5. 0.5. 0.5. When the screw is rotate one revolution, screw means circular scale, rotate one revolution along linear scale, circular scale moving distance, circular scale like a movement that we called as a pitch or screw gap. I got that definition is very important. When the screw is rotate one revolution, one full revolution, moving distance equal to the gap between two consecutive trades. It is called as a pitch. It is called as pitch. Okay, can you write another definition here? This one you write, because this definition not express the correct keyword given. While rotating one full revolution of circular scale along linear scale circular scale moving distance called as the pitch or screw gap. Pitch called as a pitch or screw gap. Called as a pitch or screw gap. While rotating one full revolution of circular scale along linear scale, circular scale moving distance called as the pitch or screw gap. Okay, I got while rotating one full revolution along linear scale, circular scale moving distance that we called as the screw gap or uh, pitch or screw gap. Pitch or screw gap. Pitch or screw gap. Okay, complete. That we call as the screw gap. Screw gap. Screw gap mean while rotating one revolution of the circular scale along linear scale, circular scale moving distance. Sandeep, I got? Sadev? Along linear scale, circular scale moving distance. While rotating one revolution, one full revolution, that means 0 to again come to 0. Full revolution එකකදී circular scale එක moving distance that we called as the pitch or screw gap. Ahmed, I got? Sadev? Good. Now we move into very important part. See the least count of the micrometer screw gauge. Do you remember in vernier caliper? Before vernier caliper, we discussed in commonly what is the least count. Commonly, the least count is the minimum measurement that can be obtained by any measuring instrument. The minimum measurement that can get accurately from any measuring instrument, that's the least count. Okay, after that we discussed the how we get the least count of vernier caliper. Vernier caliper, how we get the least count? So, main scale one segment minus vernier scale, 1 segment. Do you remember the equation? And go through again them. Okay? Go through again them and practice. Okay, now the least count of the micrometer screw gauge. The least count of the micrometer screw gauge. Okay, we have very simple practical, very simple equation. The smallest measurement that can be obtained by micrometer screw gauge. That means in other way, the least count of the micrometer screw gauge that can calculate the least count equal screw gap. Now you already know what's the meaning of this screw gap. This screw gap means the pitch within one revolution moving distance divided by the number of circular scale paths. Divide by the number of circular scale paths. Number of circular scale paths. Okay, now this instrument. Okay, how we can calculate the least count of this instrument? Okay, how we get the calculate the least count equal number, sorry, pitch or screw gap or pitch divide by the number of circular scale path. Number of circular scale paths. Number of circular scale paths. So we got it was 0.5 millimeter. No? This is a pitch. This is a pitch. This is a point. 0.5 millimeter. 0.5 millimeter. How many circular scale parts? How many circular scale parts? Good. 50. 50. 0.5 divided by 50, 0.01 millimeter. 0.01 millimeter is the common type of micrometer screw gauge. Least count is 0.01 millimeter. Do you know 0.01 millimeter means 1 meter? Sorry, not 1 meter, 1 millimeter. 1 millimeter. If we divide into 100 equal parts, 1 millimeter small distance, if we can divide it into 100 equal parts, that one part we can measure by this micrometer screw gauge. Understand the sensitivity. Okay, sensitivity and accuracy of this instrument. 1 millimeter divided into 100 part, one part we can measure by the micrometer screw gauge. How about the least count of the common type of vernier caliper? I remember. How about the least count of the common type of vernier caliper? Common vernier caliper. What's the least count? What's the least count of common vernier caliper? Yes, 0.1 millimeter. 0.1 millimeter. 0.1 millimeter mean what's the meaning? 1 millimeter divided into 10 equal parts and one part we can measure. That's the meaning. But this type micrometer screw gauge, 1 millimeter distance divided into 100 equal parts and one part we can measure this much. It is sensitivity in higher level in this micrometer screw gauge. Okay. Sensitivity is very high and the accuracy also very high in micrometer screw gauge. Okay. Okay, write down example. In common type of micrometer screw gauge, least count calculation. Least count calculation. Common type of, not it in, common type of micrometer screw gauge, least count calculation. Least count calculation. Okay, write down like this. The least count equal screw gap over number of circular scale parts. Number of circular scale part. The screw gap is 0.5, no? 0.5 millimeter. Number of circular scale part 50. Then 0.01 millimeter is the micrometer screw gauge least count. 0.01 millimeter. 0.01 millimeter is the least count of the micrometer screw gauge. Commonly used micrometer screw gauge. If it is screw gap or number of circular scale parts changing, according to this equation, you can calculate the least count and you can use. But in your exam, in your syllabus, only this type micrometer screw gauge is given. Okay, no other types are given in the exam. Okay, that's only you need to understand. That's a common and mainly and probably using and in worldwide, most people's using micrometer screw gauge. Okay, that is the today lesson. Taking measurement by micrometer screw gauge that we discussed next week, and final part of micrometer screw gauge, that means micrometer screw gauge measurement reading, how we take the zero errors of micrometer screw gauge, everything that we can discuss in the next class. I think today we did a lot of parts of micrometer screw gauge and principle of micrometer screw gauge, and parts, functions of each part of micrometer screw gauge, and the nature of each part of the micrometer screw gauge. And finally, we discussed the least count of the micrometer screw gauge, and we discussed how we get measurement using micrometer screw gauge. Every part completed for today. Okay, any doubt up to now? Any doubt from today's lesson? Any doubt? Okay, other thing. Okay, finally, give me 1 minute. I want to take you all into our group number 1, because now today I need to come from Sasip Nugegoda, then it is very tired. Okay, this class we can continue up to complete the first lesson. Now within 2 weeks the measurement is complete. Then after that, you will, after completing 2 lessons, from first week of next month, we start the basic mathematics for group number 1 students. Okay, then you can join with this one, and you can continue this class, and the basic the miss part, lesson number 1 and 2, you can cover by this class. This class I am doing bit rapidly. Okay, bit rapidly I am doing. The group number 1 is going very slowly. You please, I will let you know how to join with group number 1, and I will take as you all as a one group now, from the basic mathematics lesson from the September month. Okay, I'll let you know how to join, what are the times. Okay, I'll let you know. Okay, good evening. Good night. Sorry.